Welcome to this video on IPv6 address compression. In this session, we will cover the core learning outcomes, how to correctly drop leading zeros, and how to efficiently squeeze consecutive zero blocks. Why do we compress IPv6 addresses? Because 128-bit hexadecimal addresses are difficult to read and memorize. By using standard RFC rules, we can condense these strings for better readability, reduce typing errors, and simplify documentation. Let's review the structure of an IPv6 address. It consists of 128 bits divided into 8 blocks, or hextets. Each block contains 4 hexadecimal digits, and these blocks are separated by colons rather than dots. The first compression rule is to omit leading zeros. In any 16-bit block, you can safely drop leading zero characters. For example, 0 decibels 8 feet becomes dB 8 feet, 000A becomes A, and 0000 simplifies to a single zero. It is important to remember a crucial caveat. Only leading zeros can be dropped. Trailing zeros must be preserved to maintain the correct mathematical value of the address. For example, 1200 must remain 1200 to avoid changing the address. The second compression rule is to squeeze contiguous zeros. If you have multiple consecutive blocks that contain only zero values, you can replace them entirely with a single double colon. Let's apply these rules together. Starting with a long address, we first drop the leading zeros in each block. Then, we identify the consecutive zero blocks and replace them with a double colon to reach our final, clean result. There is a core constraint for the double colon. It can only appear once in an IPv6 string. Using it twice creates parsing ambiguity, as the system cannot determine how many zeros belong to each gap. Here are a few real-world examples. Note how complex addresses are transformed into their compressed forms, even when handling complex boundaries or multiple sections of zero blocks. To summarize, remember to drop leading zeros and squeeze consecutive zero blocks only once. You should be prepared to both compress and expand addresses and identify common violations like multiple double colon entries. In our next video, we will focus on addressing layouts and prefix lengths.